Welcome to the part two of Introduction to Python. And in this part two, we'll be discussing about pandas, the basics of pandas, why they are very important for web scraping, and some of the basic skills and knowledge required for running pandas in Python. By the end of this course, we should be able to use Pandas Library properly, upload a file via Google Colab by writing a code to help us upload the CSV file. CSV means comma separated value. Then we should be able to load and explore the data uploaded from the CSV file. We should be able to manipulate some data on it. Then we should be able to save back and export back to CSV or CSV file for Excel sheets. So how do we run our codes on how do we run our pandas code and how do we go about it? So in this case, we'll be making use of Google Colab. Google Colab is a cloud version of your Jupyter Notebook, except that it doesn't require configuration, doesn't require setting up, doesn't require installation of libraries and the like. But majority of the library you'll be making use of are already embedded in it online. Just go to colab.google, launch the application and start running your codes. So we'll be kicking in and going straight to the application, and let's now locate Google Colab. You click on the link, search for Google Colab, it will take you straight to the landing page of the Google Collaboratory platform. Then you click on New Notebook to access the online Jupyter Notebook service, which requires no setup and is free for use. So this will redirect us and automatically takes us to the notebook page in which we can start writing our code. So since we are working with pandas, let's start by writing our codes immediately. So the major thing is that we'll be starting with pandas and we'll be importing pandas library. Why do we need to import pandas library? Import pandas library. Sorry, I'm having issues with my keyboard. So import pandas, then as PD. The essence of importing pandas as PD, we are importing pandas, then we are receiving it as PD. I can receive it as P, just as if my name is Makinde and I decided to shorten my name as MK or as Mark. Whether you call me MK, whether you call me Makinde, you're still referring to the same person. So the same thing too, when you import pandas, so instead of using the word pandas, you can also use the word PD, and that's why we, in most cases, the standardized method of writing it is to import pandas as PD. So after importing pandas as PD, you click on run cell to check if the small code will execute here, completely executes. So the next is, let's check the version of the pandas we are working with. Since we've renamed pandas as PD, so we'll be making use of the shortcode PD. So let's check the version, and let's hit run. So we are working with Pandas 2.2.2, which I think that should be the latest version of Pandas. So let's now start manipulating our codes and see how it works and how we make use of the Pandas library. So click on insert code cell to continue writing your code. So now let's start with a simple age list. So we have explained in our earlier video on how to write a list. So we'll be writing a list of maybe 10 employee. So let's take the age of 10 employee. So let's say we have first person is 41 years of age, second is 56, third is 56. Let's say the fourth should be 57. Let's say another person 39, another person 59, another person 43, another person, let's say 56 again, then let's say 38, then followed by 60. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have the age bracket for 10 employees. So let's run it and see. Okay. So it will automatically store the list of these 10 employees into the age variable. So let's move to the next stage. Let's now convert this age variable into a pandas data frame. In order to do that, you still press your PD, which is your pandas. So you call the data frame function, data frame. So this will help you convert this age. It will convert this age into a data frame. So let's click on run. Let's see the output. So as you can see here, we have the output PD .dataframe.ag. So the first age here is at index 0, the second age is at index 1, third is at index 2, down to the last one at index 9. So we have 10 ages here of 10 employees. Then we have their index beside them. So next is manipulating that age and storing the data frame into another variable so that we're able to manipulate it. Here we store the list in this variable ages. So now we want to now store this data frame, this table here. Data frame helps you convert your data into rows and columns. So we want to store these rows and columns into a variable so that we'll be able to manipulate it. How do we do that? So what it means is that, let's say data frame ages equals to pd dot same pd, then we are storing this, which is the same thing as this, into this variable df ages. So we can just say df ages dot head means you are just specifying the number of variables you want to view at once. So if I'm viewing 3, it will show the first 3 ages. If I'm putting 4 here, it will show the first 4 ages. So let's check and see. If I scroll down a little bit, okay. So since I'm having the head is 4, it's showing 1, 2, 3, 4. If I make it 3, then it will only display 3 values. So let's now move further to dictionary. So let's now combine this age with the name of the employees. So we want to combine the name and age of the employees. So in this case, we'll be making use of the dictionary part of Python. So how do we do that? So let's say the employee data, let's say employee data equals for dictionary we use the curly bracket open and close. So we'll start with the main key of the list. So The main key here is the name of the employee, followed by the name of each employee. So, and that will be represented as a list which will now be stored inside the key. So for each employee, let's start with Tolu is 41 years of age. Garba is will be 56 years old. Sorry. Emeka will be 56 years old too. Shola, say Shola, take the next age since we are looking at 10 ages here. So Sean will pick the next one. Kingsley, pick the next one. That will be 7, I think. Buhari will pick the next one. That will be 8. Ajay will pick the next one. That will be 9. Sada pick the next one. So how many names do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then let's add one more to make it 10 since we have 10 each there. IB, let's make it, that makes it 10. So let's now add the age to the names. So the ages, or let's say age key full column. Since we already stored our age list in the variable ages as a list, we don't need to start retyping it. We already have it here. We already have it here as this and stored in this. So what we need is this name here, ages, instead of retyping everything in the square bracket. So this should do. So let's run it, which I think it ran. Then let's print it out and see how it looks like. So okay, we now have our dictionary, and Tolu is 41, Garba is 56, Emeka is 56, and the IB is 60, Sada is 38. So let's move to the next part of the code now. So let's now start manipulating our employee data and see how it works. So next is to convert the employee data to a data frame and store it into a data frame name. So let's say employee data equals to I want to convert it to a data frame. That will be pd dot, what are we converting? We are converting the employee data. No, we are converting the employee data, but we are using the function data frame. So employee data. So after that, let's check after converting it. We want to convert this, what we have here, into a table, to a data frame table, so that it will be more presentable and easy to manipulate. So df underscore employee data dot head. So we are displaying 3 in the table. Let's see how it looks like. So we now have our data frame for employee data with a name assigned to each of the age. So we now have Tolu 41, Emeka 56, Garba 56. So next is now to confirm how many number of columns do we have now. I think we should have 2. Previously we have 1, just the age. But let's confirm df underscore employee data dot columns. This should help us confirm the number of okay, we now have index name and age. So we now have 2 columns in our code. So next is, if you notice that in this table, let's now assume we want to make the name the index. We want to eliminate this 0, 1, 2. We want to make this name the index so that we're able to calculate, we'll be able to manipulate this age value here. So what you need to do is start, define, set the index. You set the index as you set the index of you set the index as name. You set the index as name. So the employee data frame, then we are setting the index. Let's see, index. We are setting the index. What index are we setting? We want to make the name the index, then comma in place true. So just make sure you have the in place as true, then which I'll later explain what it means. So employee data. So let's see what happens. Okay, so we now have our name as index, then our age 41, 56, 56, 57, 39, 56, 43, 56, and IB is 60. So we've now eliminated the indexed value of 0, 1, 2, 3, 4, 5, 6. So let's now say there's a question that says, okay, let's get the average number of age we have in this data frame. Let's know the number of ages we have. Let's assume we have several millions of rows. You can't start counting those rows one after the other. So what it means is that you can write a code to describe that data. So it will describe that column age. It will find the standard deviation, the minimum, the mean, the average, the max. So in order to do that, just call the refer to the data frame again, which is the employee data dot, then you just call the function describe. This will help you to describe the age, since the name is already the index. So we now have age count, we have 10, the mean is 50, the standard deviation is 9, the minimum is 38, 25% had to have 41, 50%, 56, then the maximum is 60. So next is to now check maybe the basic information. Maybe you have a data frame and you want to know what the data frame is made up of, and what are the components. So you can just call the data frame and call the info function to help you check the basic information of the data frame. This tells us we have 10 entries from Tolu to IB. Then data column is 1, the column name is age, and the number of entries is 10. So let's now say next is we want to transpose. We would like to transpose the data frame table. We want to transpose it. So we want everything in this column to move to the row, while everything in the row column to move to the column. Everything in the row to move to the column, everything in the column to move to the row. So, and want to do that, and that's what we call the transpose. So let's now transpose by saying, by typing the df employee, let's see, employee data dot t. The t function will automatically help you transpose it, okay, which it has done. So we now have how many? We now have Tolu, Garba, Emeka, Shola, Shen, Kingsley, Buhara, Ajay, Sada, and IB as the column. So the system has automatically transposed their record here. So the new columns are now this. If you want to confirm the new columns, you can just simply type df underscore employee data dot t dot columns. So let's see what are the columns values. So you can now see the new column are now Tolu, Garba, Emeka, Shola, Sheon, Kingsley, AJ, Sada, IB. So those are the new columns. So next is now we want to check. Let's assume we want to multiply. The question says multiply the ages of every employee by 2. How do we go about that? Simple. Since we have the data frame for the employee data frame, just simply type the employee dot multiply dot. So in order to view multiply by what? By 2. This will multiply the age by 2. Then want to see the result. So dot head. After multiplying, let's check the result. Dot head. So let's run it. So the age of Tolu instead of 41 is now 82. Right, that of Grauber instead of 56 is now 112. So this helps. Let's assume we want to divide. We want to divide the age by 2 instead of multiplying by 2. The same thing. So let's put it in bracket. Your df employee divide by 2 dot, let's see the value of what we have. So let's check. So Tolu is now 20.5, while Garba is 28 and Emeka is 28. Let's assume you want to multiply. You want to multiply the data. You want to multiply age. You want to multiply age by age. You want to multiply age by age. You can also do that. You can multiply the age twice and see what happens. So let's say employee. That should be multiply asterisk df employee data. So dot head. Let's view the data. So if you multiply it, age will now become a 1681, because when you multiply 41 by 41, that will take you to 1681. So let's now check for logical operators and see the age that is greater than 40. Let's say they now ask you to filter the employee list and check those employee with ages greater than 40. Is just simple. You call the data frame, then you put greater than 40, and you hit the run. That should show the total number of employees with their age. So Tolu is greater than 40, that returns true. Garba is greater than 40, it returns true. Emeka is greater than 40, returns true. Sheon and Sada are less than 40 years of age, so it will return false. The next phase now will be writing, manipulating codes from Excel file. We want to manipulate codes from Excel file. What we did now was to enter our data manually from, we typed the list manually, but in this case we want to fetch the list from our Excel file, from our CSV file. We want to fetch the list from the CSV file to make the work much more easier and to manage the record. So what list are we fetching? So let's go through the list. I think I have the list here. Okay, we'll be taking a look at this list, which has employee ID, the name, the age, the department, the salary, the city, the join date, the gender, the experience, and the performance rating. So we'll be looking at a file name called employee.csv, and it contains 25 employees records. So we want to load it into our pandas data frame and manipulate the record. So let me show you how the data look like. Let's see. Okay, this is the employee. Okay, I think we have it open here. So this is the record in our Excel. So we want to load this record into our pandas data frame and see how it works. So how do we go about that? First thing to do is to import the file function of Google Colab. Is to import the file function of Google Colab. So let's start by importing the file function of Google Colab from. So let me make use of my on-screen keyboard. Sorry, I think I'm having issues with my space here. From Google Colab, google.colab, we are importing the file function, the files function. So from Google Colab, we are going to import the file function. So from Google Colab, we'll be importing the file function. So let's run it and see what happens. So okay, I think we are good to go. Then next is we'll write code to help us load the data from our system. Write a code to help us load the data from our system. We'll write a code to help us load the data from our system. We'll write a code to help us load the data from our system. That will be files.upload. Then we'll call the function upload to help us upload it. So with this line of code, the system will prompt the user to upload the file. The system will prompt the user to upload the file. So if I run it now, I'll have a prompt which tells me to choose the file and then for automatic upload. And that's the essence of this short code. So without the Google Colab import files, you might not be able to do this. So you call the Google Colab import files, then you make use of that file function to upload. So whatever we are uploading, we'll be storing it inside this upload. So let's proceed to upload our file. Let's locate our Excel file. Okay, this is it, employee. So we're uploading this Excel file. Okay, done. So we are done uploading. Then next is for us to now, since we've uploaded the record employee.csv, so let's start manipulating the employee.csv. But we need to load that employee.csv into a data frame. So how do we go about that? So what data frame, what should we call the name of the data frame? Let's call it df employee, or df emp. So whatever name you call it, it's fine. Depends on. So let's now read that CSV file from the Excel file into the df employee. So you just type pd dot read underscore csv. That's the function to read an Excel file, a CSV file into a data frame. So pd.csv, then the name of the file. I think the name of the file is employees underscore extended dot csv, just like we have here. This is the name. This is what we uploaded. So we have to make use of this name and return it back here. Then after uploading, after reading it to df, so let's now check the first 3 value or the first 5 value of our new pandas data. So let's see. Okay, with this now we've been able to successfully move data from our CSV file uploaded online into a new data frame called dfemp. So we now have our new data frame which has the employee ID, the name, the age, the department, salary, city, joint, gender, experience, and performance rating of all members. So let's start manipulating the dfemp data frame. So let's now say we are being asked to we are being asked to, let's say, to filter. They ask you to filter the data frame and they show employees working in the IT department. I think the department column is this, and we have some employee working in the IT. So we want to filter employees working in IT departments. So what we need to do is let's save it. Let's save that data. Let's call it IT employee or IT employee, depends on the name you are giving it. So we want to filter employees. The data frame is DFEMP. Then in order to access a column, in order to access a column value, you simply type the data frame name, then followed by the square bracket. So, but we are now being specific. We want to compare a data frame with a value. We want to compare a data frame with a value. So we want to compare the department with the IT value and say that, okay, if you belong to an IT department, then your record should be pulled out. So in this case, we will now go specific to the department, which is the DFEMP. You have a nested list inside another nested list now. So we are now department. Then is the department equals to IT? Is the department equals to IT? So let's print our IT employee and see what we have. So from this now, we've been able to filter 1, 2, 3, 4, 5, 6, 7, 7 employee in the IT department. So we can also check other member of the department. We can change this IT to marketing and see what we have. Okay, we have 3 members in the marketing department. Let's now check how many employee lives in Lagos, or how many employee, yes, lives in Lagos. So in order to do that, the column name we'll be dealing with here will now be city instead of department. So we'll change the department to city, then we'll change the value to what? To Lagos. So let's see how many live in Lagos. So we have Tolu lives in Lagos, Diana, Hannah, Garba, Karim, Nina, Kyunshim. So how many lives in Kano? Let's check. Okay, 4 of them lives in Kano. So with this, you can easily manipulate some of the data in your Excel file. Next is, let's assume these salary rates are being earned in dollars. Let's now convert that dollars to naira and compare it and see, okay, yeah, Tolu is earning 70,000 in dollars. Let's view the equivalent in naira. You should be able to do that. In order to do that, let's simply do that by typing our uh, data frame. So since we are going to do for naira, that means we'll create another column, convert the normal data frame salary, we multiply it by 1007. I think that should be the present rate, and store it in the data frame. So let's start with the data frame employee, which is our data frame from the employee. So that means we'll be working with a new column. Let's call it salary naira. That's a new column in which we don't have in the existing one. So we will now want to calculate the FEMP, the normal salary which is in dollars. Normal salary which is in dollars, we'll multiply it by, I think the present rate is 17. Okay, this should help us. This should help with conversion of the present salary to naira salary. So let's now view all the salary and the names in a single sheet. So let's say DFEMP, DFEMP. Okay, the first square bracket, then the second square bracket. So let's have name followed by, I think, name followed by, sorry, name followed by present salary in dollars, followed by the new salary, sorry, the new salary in naira. That was salary that's called naira. So let's see how it looks like. Okay, so we now have the name, salary in dollars, and the salary in naira after conversion. We can also add a table label to this. So let's just print, let's say print, then let's call it salary in naira. I think that should add a table header to, okay, that should add. So we now have a table label for the table. So next is, let's now assume that they now ask us, okay, group employees by department and calculate the average salary per department. You can also do a group by the city and calculate the salary by city. So it depends on the manipulation you want to go about. So if we are grouping the employee by department and we are calculating average salary, so let's create a variable. Let's call it AVG, average salary. So let's call it average salary. We want to store it in average salary. Then DFEMP, that's our data frame, dot we are grouping by. So the group by what? We are grouping by, so we should group by department. Then after grouping by department, then we want to calculate the salary, the average salary, and in order to have access to the column for salary, so that will be the square bracket salary dot that should be dot mean. Mean will help us calculating the average. So I think this should do the trick. So let's print AVG salary thing here. Okay, so let's see. Okay, so finance average salary is $62,000, HR is $64,000, IT is 67, marketing is 68, sales is so if you are to group by city, you have to group salary by city, just simply change group salary by city, then let's run it. So Abuja salary average is 64, Ibadan is 67, Kano is 63, Lagos is 63, Port Harcourt is 60. So let's now assume that we've been asked a question to filter employees by experience. That is, we want to know those who are employees with more than 5 years working experience. So in order to do that, let's create a variable name. Let's call it experience, or you call it XP, or you call it Expo. So you can give it any name. So we need to embed, okay, the data frame. Let's call the data frame. Then we embed it. So we want to check EMP, embed another data frame. Then experience. I think the column title is experience. Let's confirm the name of the column so that okay, experience. Okay, the column name is experience. So let's call the column experience. Sorry. Then experience should be greater than 5. Experience should be greater than 5. If the experience is greater than 5. So let's see the number of employees with experience greater than 5 experience. This name should tally with what we are printing here, since we've stored those greater than 5 into experience here. So we are recalling this here, or you can call it XP. Let's call it XP. So if we are calling XLP, this one too will be XLP. So XLP, XLP, then another inner bracket to print, you know, print the name alongside the experience of those greater than, alongside the experience. Let's see, experience column, experience. So let's see how it runs. Okay, I think from the list we have about 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 members have experience uh, greater than 5 years experience. So we can also sort by performance rating. Let's assume we want to sort by performance rating from the highest to the lowest, or from the lowest to the highest. So those with the best performance, monthly performance or yearly performance rating will be promoted. So how do we sort them? So in order to do that, let's call the variable name sort performance. Let's just call it sort performance, or you call it SRTP to shorten it. So what are we sorting? DF, what's our data frame name? Is DFEMP. So we want to sort it. We call the function sort values. There's a function called sort values. So what are we sorting it by? We are sorting it the by which column? The performance. Let's check the name of the column we are sorting it by. Okay, the name of the column is performance rating. So let's copy it. So we are sorting it by the performance rating. Okay. Yeah. If you are sorting by the performance rating, ascending order will, when set to false, will be from the highest to the lowest. But when you put ascending order as true, it will set it from the lowest to the highest. So let's now print out our sorted record and see how it looks like. So SRTP, your square bracket, another square bracket, the name and the performance rating. So let's run it. So the highest performance rating here is 4.9 by OSAS, and the list is by Victor 3.1. Let's change the ascending to true and see what happens. So it automatically reverts it. Victor comes up, then OSAS comes last. So let's now say all what we've done so far, we want to export it to Excel and make it downloadable for learners or for submission. So you simply go to, you simply type your data frame. You're still referring to the same data frame, DFEMP of employee dot. So we want to convert it to CSV. So to be dot to CSV, that's with the function name, then the name of the new file. Let's call it employees modified .csv. So make sure you add the index equals false. So the index value is false here. Then file, let's call the file function files dot download. Then what are we downloading? The same file name, employee modified CSV. So let's run it and see. Okay, with this now we've been able to download our employee modified file. Let's open it and see. So we now have employee modify. You can see that this new data is different from, it has added the salary in naira to the modified record. So, and when you are done, you can save your file name as your name. My name is Makinde. So let me save it as Makinde. Then you go to file, then you click on download to download the file. Then after downloading the file, I'll create a space for you to upload that file as an assignment so that you attach your assignment codes, then I'll be able to confirm your assignment. So I'll be giving you an assessment to do almost the same thing to another file name. So you'll be working on another Excel file and you'll be using some of the skills you've learned so far. Thank you very much. Have a wonderful coding.